Hey, this is Joe, and today let's talk about multiplying polynomials. That is, how do we find the result of multiplying these polynomials? And one method you can use is using the distributive property to distribute one of the polynomials into the other, and then do a couple steps and you get to the product of the polynomials. So let's begin with a really easy example, using the distributive property. That is, how do I multiply out 5x times x to the third power plus x. Here, 5x is a polynomial, and x to the third plus x is a polynomial, and we have them multiplied together. And if you recall, the distributive property is, if I have a times, in parentheses, b plus c, I can distribute a into b plus c by multiplying a by b and multiplying a by c. And so, within this example, we can think of this 5x on the outside as our a, the x to the third power as our b, and this x to the first power as our c, and then we can just use the distributive property to get 5x times x to the third plus 5x times x. And then we would multiply each one of those terms together to get 5x to the fourth plus 5x to the second. And so this is just kind of a small review of the distributive property with an easy example. And if you need more of a review with the distributive property, check out this video here. Now let's work with the example that I showed at the beginning of this video. In other words, how do I multiply x to the second power plus x plus 3, all that times x to the fourth power plus x to the third power minus 2. And so if I was to add an extra term up in this distributive property within the parentheses and have a b plus c plus d, all that would end up doing is when I would distribute the a in, I'd also have to add a plus d as well on the right side. And the only reason I'm doing this is this allows us to kind of match this distributive property to this given example. In other words, we can think of our first polynomial here, the x squared plus x plus 3, as a, and then our second polynomial, we could think of the first term as our b, the second term as our c, and the third term as our d. And then looking at it this way, we could then multiply a by each one of those individual terms in the second polynomial. We would have x squared plus x plus 3 times x to the fourth, just the a times the b term. I would then multiply my first polynomial by x to the third power, and I would also multiply my first polynomial by negative 2. And this is a legal use of the distributive property. And now, we're basically going to use the distributive property again within each one of these terms. In other words, I'm going to take x to the fourth power and distribute it into the polynomial x squared plus x plus 3. I'm going to take x to the third power and distribute it into x squared plus x plus 3. And I'm going to take negative 2 and I'm going to distribute it into x squared plus x plus 3. And that is how we get to this third step here. Now, within each one of these terms, we're just going to multiply our terms together. So x squared times x to the fourth is x to the sixth power. X times x to the fourth is x to the fifth power. 3 times x to the fourth is 3x to the fourth. X squared times x to the third is x to the fifth. X times x to the third is x to the fourth. 3 times x to the third is 3x to the third. X squared times negative 2 is negative 2x squared. X times negative 2 is negative 2x. 3 times negative 2 is negative 6. And if you need a review on how to multiply a variable times itself with different exponents, you can check out this video here. And now that we're at this fourth step, all we're going to now do to take it home is combine like terms. It looks like we have two terms with x raised to the fifth power. We have x to the fifth plus x to the fifth, and that will give us 2x to the fifth. It looks like we have two terms with x to the fourth power. We have 3x to the fourth plus x to the fourth, and that will give us 4x to the fourth. And it doesn't look like any of our other powers of x's match, and so we get our final answer down here. And if you need a review of how to combine like terms, you can check out this video here. Now, the beautiful thing about this method is that it can be used with any size polynomials. In other words, if you remember, when you're taught how to use FOIL in a classroom, that's when you're multiplying two binomials together. And you can't use FOIL the moment one of your polynomials isn't a binomial. In other words, if I have more than or less than two terms within one of my polynomials, I can't use FOIL. And so just to show you how to use this method with two binomials as an alternative to FOIL, let's work with this problem here. We have x plus 3 times 2x minus 4. We will select one of our polynomials to be distributed into the other, and it doesn't matter which one you select, but in this case, let's let x plus 3 be the polynomial we're going to distribute into 2x minus 4. And the way we do that is we take x plus 3 and multiply it by each one of the terms within the other. So we'll take x plus 3 and multiply it by 2x, and we'll take x plus 3 and multiply it by negative 4. Now we're going to then use the distributive property again. We're going to distribute 2x into x plus 3, and we're going to distribute negative 4 into x plus 3 as well. And so we'll end up getting x times 2x plus 3 times 2x plus x times negative 4 plus 3 times negative 4. To bring it on home, we're going to then simplify the multiplied terms by just multiplying them out. So x times 2x is 2x squared, 3 times 2x is 6x, x times negative 4 is negative 4x, and 3 times negative 4 is negative 12. And finally, we're going to then just combine like terms. And the only terms that are like here are 6x and negative 4x, so when we combine those, we get 2x. And so our final answer is 2x squared plus 2x minus 12. And so this process will get you the same answer as if you use FOIL to multiply two binomials together. So, just to review, the steps for this process are if I have a product of two binomials, I distribute one of them into the other. I then distribute the solo terms into the first polynomial that was distributed. I then multiply out all of my terms, and I combine like terms to get to the final answer. And in this example, it looks like I had no like terms at the end, and so my final answer came after I finished step 3 here. And once again, I really like this method of using the distributive property to multiply two polynomials together because it's useful for any size polynomials. FOIL can only be used when you're multiplying two binomials together, and I think it's hard for students to sometimes understand when they can and can't use FOIL, and so instead of even teaching FOIL, you end up just showing them this process so that they're able to multiply any two polynomials together. I'm Joe, and thanks for spending some time with me.